Hello and welcome to episode 21 of Nelson's Corner with your host, Nelson LeKay. Hey, Nelson.
Hey.
Hey, all right. Don't knock me down with all of this enthusiasm you have. We will be continuing the card game engine tonight. This will be part 12, and I do believe we will be looking at the event publishing system as long as Nelson hasn't had a change of heart. Is this correct, Nelson?
Yeah, we're going to be taking care of pretty much all of these interfaces down on this column.
Okay, fantastic. So, yeah, let's go ahead and just jump right in.
Okay, first I'm going to create a class, and then I'm going to create a test. And the class I'm going to create two classes. I'm going to create the IEventPublisher class. But the IEventPublisher class isn't actually very interesting. Basically, it serves as just a collection of what I call event chains that are published whenever an event gets asked to be published by the IEventPublisher or by whoever has
okay,
reference.
Let's try that one more time, because that was like the largest twisted number of words ever. No, I'm not saying we got to re-record the video. I'm just saying we're still recording. Say that again.
We are?
Yeah.
Oh. Anyway, so we're going to create the IEventPublisher, which is a basic interface that just allows us to add what are called event chains.
Okay.
Those event chains are then invoked whenever somebody tells the IEventPublisher to publish an event.
Okay, very cool.
Okay. So what we're going to do is just create a basically just a private read-only list of event chains called chains. We're going to instantiate this field in our constructor. When we add a chain, we are going to add a chain to the chains field. And when we remove a chain, we are going to remove a chain from the chains field.
Makes sense.
And then when we publish, we're going to loop through all of our chains and publish the event. And so basically, the reason I have this working the way it does is that there are multiple ways that events can get out of the system. The main way is that events are going to be invoked on game objects, all the game objects that are going to be in our runtime project. In addition, events are going to be invoked on all of our card objects, which are considered to be game objects. But on top of that, we also have events being published to the query model, which needs some special code wrapped around it in order for it to work with WPF properly. Even more than that, we have events that are going to be shot off over the wire. So we'll need a bunch of these different chains to be implemented for us to be able to handle the multiple scenarios that the IEventPublisher works under.
Okay.
So I'm not going to bother to test this class. Just like the game object repository, if this class is broken, either I don't know C# or the BCL is broken, which are both very unlikely. So instead what I'm going to do is implement a class that we are going to test called the in-process event chain. Now the in-process event chain is basically going to allow you to register a ICanHandleEvents object. And then when we publish, we are going to invoke code through reflection on all of the IEventHandler interfaces that this object has.
Okay.
So in order to test it, let's go ahead into our test project and create a IEventPublisher or a in-process event chain test. And the first test is going to be straightforward. We're going to have a class called IEventHandler. He's going to implement ICanHandleEvents. And he's not going to do much at the moment because we also need an event. So we're going to write an event 1 that implements IEvent. Now event 1 is just going to have a very basic property. Let's just call it int myInt. The idea is that we are going to this object right here, this IEventHandler object, or this IEventHandler class, is going to implement the IEventHandler interface of type event1. Then I'm going to implement the member, and we now have a handler. Basically, for testing purposes, all that's going to do is it's going to set the myInt property on this IEventHandler class to what was passed in for the event. This is how we're going to prove that this class handled the event properly. Finally, we'll have a void can handle basic events test class or test case, and we'll give it a test attribute. And all it's going to do is it's going to instantiate our event handler. It's going to instantiate our chain. It's going to register our event handler with our chain. Then we're going to declare a constant, const int expected, and we're just going to type in some random numbers. And then we're going to say IEventChain.publish new event1 pass in expected. And then we're going to say EventHandler.myInt should be expected. So yeah, so how do you feel about this test case?
Yeah, I'm feeling pretty good.
So that's the code that we need to work, and let's go ahead and run this just to prove that it is indeed going to be red, because, well, if it was green, I would be very worried. Because that means C# does not behave in the way I thought it would. So basically when we register a object, we're going to store all of our handlers inside a very scary looking structure. Ready for this? A dictionary of type and of type list of type tuple of type ICanHandleEvents and method info.
Nelson, okay.
And we're going to call this handlers. If you look at it, it does make sense. We're listing, we're looking up by the type of event, and then we're getting a list of game objects. Well, you can think of these as game objects and methods that get invoked.
Right, right.
And
no,
remember,
I see where you're going from. It's just, it's just funny.
Remember, though, that ICanHandleEvents is specifically not a game object for a reason. In certain cases, especially with the query model doesn't actually have any game objects. Game objects are reserved for the runtime and for the cards only. So my problem is how can I represent an object that can accept events outside of being a game object, which is why I came up with the ICanHandleEvents interface. But if you remember, if you look at the IGameObject interface, he actually inherits from ICanHandleEvents himself. So yeah, so the first thing in our constructor, we have to instantiate this awesome data structure of data structures of data structures. And then in our register method, we're going to write some code. The first thing is if already registered. Already registered event handlers, then return. Already registered is going to be a straightforward method. It's just going to do some code. And then, yeah, so basically we're going to loop through all of the handlers of this particular game object type and then figure out if any of them has, or I'm confusing myself right now because of this gnarly data structure. Basically, we're going to loop through all of the objects inside of our list and see if they're actually the same as our event handlers.
Okay.
If that makes any sense. So let's go ahead and say for each var kv in handlers, and then just for each var handler in kv.value, if handler item 1 is event handlers, then just return true. Otherwise, return false. I just wanted to point out this code really quickly before I had ReSharper do all the dirty work for me. So basically, the nested for each loops is being compacted into a select many. So this will return an IEnumerable of all of the tuples in this entire dictionary. And then we're saying if any of them have a game object that equals a game object we passed in, then return out true.
Okay.
So yeah, so the next step is we need to get the type out of our event handlers. So the game object type, or let's just call this the event handlers type, because they're not necessarily game objects, even though I'll slip up and call them game objects every now and then. And then we're going to do a scary link statement again, just like we did before, where we do from enter in event handlers type dot get interfaces, where enter is generic type, where enter dot get generic type definition is equal to type of IEventHandler, empty generics. Then select out a new object, not a new void because that doesn't make any sense, a new object. And then we're going to end this with a .toList. We're going to select out the event type, which is going to be the enter.getGenericType arguments.first.
There you go.
And then we're going to select out the method, which is going to be enter.getMethods.first. Now we're going to loop through all these guys. So for each var handled event in handled events, we're going to say event type equals handled. Actually, never mind. We're going to say item to add equals tuple.create, and then basically we're going to create a tuple of type event handler, or ICanHandleEvents and method info.
Right.
So the first thing is going to be the event handlers, and the second thing is going to be handled event dot item 2, or handled event. Oh, sorry, this isn't a tuple. This is a anonymous type. Then we're going to extract out the list of tuples of ICanHandleEvents and method info, and we're going to call it method list. And then we're going to say if handlers dot try get value. The key is going to be our event type, which is our handled event dot event type. Our output is going to be this list, this method list. So if we filled this list with a reference to the list that's in the dictionary, then go ahead and add it to it. So method list dot add item to add. If not, then do handlers event type, which is going to be handled event dot event type, equals new list blah blah blah, and then as a collection initializer we're going to pass in item to add.
Cool.
So this will extract all of the IEvent handlers out of a type and add them to our awesome data structure.
Okay.
So finally, our publish is going to do two things. It's going to say we're going to actually do we're going to abstract publish a little bit. We're going to say send to handlers, pass in event and type of IEvent, then send to handlers, pass in event and pass in event.getType. The reason we're breaking publish out into two is we want to have the ability for people to have a catch all event handler. So if they implement IEventHandler of type IEvent, we want that to fire off for all IEvents that we publish. Does that make sense?
Mm-hmm.
So we're basically breaking that into two, and then we're creating another method, and then this is going to be event type. So first, we're extracting out our ICanHandleEvents tuple. If only C# supported type defs. And then we say if not handlers, try get value, and then the type is going to be the event type, or the key is going to be the event type. The output is going to be the subscribers. Then just go ahead and return. I mean, it's not a crime if nobody has handled this event yet. But if they have, then we're going to go loop through all of the subscribers and do invoke subscriber on sub to item 1, which is the object we're invoking on, and sub to item 2, which is the method info we're invoking on. And the reason I'm actually breaking this out into yet another method is because this method is actually going to be protected and virtual. And I'll talk about why in a second after I rename these two, or an handler object and method. And actually, we forgot the most important thing, which is the actual event we're passing in. So then we're passing in IEventEvent as the third parameter. Basically, the default implementation of this is just going to do method.invoke, pass in the event handler object, then as an array or as a list of arguments, pass in the event. Okay, the reason we're making this virtual is that we want to make it easy for people to write similar code in the future. And the similar code is we want to have it easy for people to use the IEventHandler idiom that we've kind of invented in this code base, but in a different way. So remember how I said that in WPF we have to sort of wrap our code that we execute in something special?
Mm-hmm.
Basically what we would do is we would subclass out this in-process event chain and give it a different implementation for our invoke subscriber, wrapping it in the code we want to wrap it in order for things to work properly in WPF. But now that that's all done, we should get green. And we see that works.
Cool.
So, yeah, I guess I can also test catch-all events just because, just for fun. Let's add another test. Public void can handle catch-all events. And then we're going to write another game object. We're going to write a catch-all handler, which implements ICanHandleEvents and IEventHandler of type IEvent. And then we're going to do the same thing, actually. We're just going to cheat in this, because we know that the only thing we're going to be sending sending this guy is this event right here. So we're going to say myInt equals event1 event.myInt. And so now let's go ahead and pretty much copy this exact code, except for instead of instantiating a new event handler, we're going to instantiate a new catch-all handler. And this code should work just as well as the other test, and we get success. So that means our basic event handlers, our typed event handlers are working, and our catch-all event handlers are working, and that's about the extent of the functionality of the in-process event chain.
Very cool.
So yes, that about wraps it up.
Okay, cool. So this will just be a little bit of a shorter video, but in the next one, we're going to jump over to
commands.
Awesome. All right, ladies and gentlemen, thank you very much, and that will wrap up this video.